Hello everyone, I'm here to give you a simple example of Prim algorithm. So Prim algorithm is an algorithm that helps us to find the minimum spanning tree of a given graph. Right? So in this case, suppose we have a graph which is like this, and we want to, starting from node A, we want to find a minimum spanning tree. And firstly, we should understand that we have to fill in a form which is like this, right? So for each entry, currently it has two values, right? The first value means the smallest weight of an edge which connects to the node to the spanning tree. For node A, is already a part of our minimum spanning tree, right? It's a starting node. So there is no edge that connects node A with this minimum spanning tree. So the weight is 0 for node A. And for node B, C, D, and E, because currently they are not a part of our minimum spanning tree, right? So the connecting edge is of length infinity, right? So initially they have infinity weight, right? So firstly, because our starting node is node A, right? So we must mark node A as connected because it is already a part of our minimum spanning tree, right? So we use check symbol to mark the node A as connected, right? And then we need to we can interpret node A as our minimum spanning tree, right? Because currently our tree only contains one node, which is node A, and we take this node A as a tree, and we ask ourselves, what is my nearest neighbor? So basically, we can find that for this tree, its nearest neighbor is node E, right? So in this case, we are greedy that means we only accept the nearest neighbor, right? So we connect node E via node A, right? So for node E, we have updated values, which is like this. The check symbol means that we have already connect a node E to our minimum spanning tree, right? And we connect the node E via node A, right? And the length of the weight, the weight of the edge is 2, right? So we connect node E via node A, and the length, the weight of the connecting edge is 2, right? That is what these values mean. And then after connect node E, we can take these node A and node E as a whole part as our minimum spanning tree, right? Currently, our minimum spanning tree has 2 nodes, right? And then we can ask ourselves, if we have a tree like this, what is my nearest neighbor? Remember, we are greedy. We only accept the nearest neighbor, right? So in this case, we can find that node C is my nearest neighbor, right? So we connect node C and we update node C, which is like this. We connect node C to the minimum spanning tree via node A, right? And the weight of the edge is 3, right? So that is what these values mean. And then after we connecting node C, we can take this part as our minimum spanning tree, and we ask ourselves, what is my nearest neighbor? In this case, we can find that here node B is our nearest neighbor, so we connect node B with the minimum spanning tree via node A, right? And the width of the edge is 4, right? So here we update node B, which is like this, and then after connecting node B, we can back to here. After we connecting node B, we can ask ourselves, if we have a minimum spanning tree which is like this, what is my nearest neighbor? So, and apparently currently we only have one left node, which is node D, and we must connect the node D with our minimum spanning tree. So what is the minimum? What is the smallest weight? The smallest weight is 5, right? So we can connect either in this way or this way. We can choose either way. This time we choose here. We connect node D via node B to the minimum spanning tree, and the weight is 5, right? So we update our node D at this. And then after we finished all the nodes, we have marked all the nodes as connected, right? They are all checked. And then we can ask ourselves, what lines, what edges that we use. We connect node A to our minimum spanning tree via node A, and we connect node B to our minimum spanning tree using node A, right? So we have an edge AB, which is of length of weight 4, right? The weight of AB is 4, and we connect node C to our minimum spanning tree via node A, and the weight of edge AC is 3, right? And then we connect node A to our minimum spanning tree via node B, and the length or the weight of the edge BD is 5, right? And lastly, we connect node E to our minimum spanning tree via node A, so that we use the edge AE, right? And the weight is 2. So basically, this is the idea of how to use Prim algorithm to find a minimum spanning tree. That's all. Thank you.